Hi everyone. Now that you know what double stars are and why they're important and how we study them, and hopefully you've given some thought to what makes double star systems interesting, it's time to find 3 interesting double star systems of your own. Make your image requests and be ready to analyze those using Astro ImageJ. On a sample FITS file so that you know you're ready to analyze your own images when they come back. We need to make sure that any stars we choose are currently visible in the night sky. If it's January, for example, the night sky, the part of the Earth pointing away from the sun, is looking at the constellations Taurus or Gemini or Cancer. And if you're trying to image a double star system in Sagittarius, you're going to be out of luck. The sun is blocking it. So you want to pick a right ascension within plus or minus 5 hours of one of these best right ascensions listed for the time of year when you're making your image request. The stars also need to be at least 5 arc seconds apart. If they're closer than that, then the Skynet images will show both stars as a single blur, and that won't be very helpful if you're trying to measure the position angle and separation of one relative to the other. And also they need to be about the same brightness. If they're more than 3 orders of magnitude different in brightness, then you're not going to be able to get them both on the same image. So this delta mag, Dmag, needs to be less than 3. So in order to find some stars that fulfill these criteria and will hopefully be interesting for you to study, you're going to use Stelladopy to find the stars, and then Skynet to make the image requests. So we'll go to Stelladopy, this website that's listed on the slide, goaction.it. Stelladopy means double star in Italian. It was written by an Italian researcher by the name of Gianluca Sordiglione. I love saying that name. And you find some stars that have a separation greater than 5 arc seconds, delta mag, less than 3, and maybe some other criteria of your own choosing. For this assignment, I want at least one of the stars to have a known orbit so that you can compare a measurement that you make to the measurements that have been made in the past. So let's do it. We go to Stelladopy, we click Search the Database, and then we go to Advanced Search. And I'm going to say right ascension equal to, actually, let's say between 3, 13, between 3 hours and 13 hours. And then I'm not going to put a restriction on declination because Skynet telescopes are kind of all over the world. Then I will say I want my delta magnitude less than 3. Separation greater than 5 arc seconds, so more than 5 arc seconds. And let's say known orbit equal to yes for this search. And then I click search the database. And I come up with 17 records. So let's just show this first one. This is my first system. It has an orbit. This is the primary star, and these are positions of the secondary star relative to the primary star plotted out for a long time in the future. Here's the data that is had for this orbit. So it looks like we've seen this much of the arc of the orbit of these 2 stars, and from this we've inferred the rest of the circle. And so it looks like it would be great to make another measurement of this system and see whether it does fall on the arc. The last observation was in 2013, so it's been a few years, and we can make another observation fruitfully. So here's one system, and I'm going to copy the URL of this system into my table and say this is one of the systems that I'm going to observe. This has a known orbit. And you might want to find other systems that don't have a known orbit, so not checking that checkbox as well, and put some of those into your table. And we'll be copying some of this data. For example, the primary proper motion primary motion in RA, primary motion in DEC. So this is the proper motion of the primary star. Here's the proper motion of the secondary star. That's going to go in your table along with some of the other data. So then you find stars that way, and you then need to actually go and make a Skynet image request. So let us do that. You go to skynetjuniorscholars.org. You'll have to log in if you haven't already logged in. And log in. And then go on over to click Go to Skynet in the upper right corner. It sometimes takes a minute to load, but once you're there, you go to My Observatory, Optical Observing, and that's where you'll put in your image request. So Add New Observation is what you want to select. And you put it in by the right ascension and declination. So here's my observation name. Let's see, what's the name of this star? I'll copy that in there. So add observation. Here's going to be my observation name. And then the right ascension is right here. Up at the top in this bar up here at the top. So I'll put in my right ascension. I think you need to put colons between the hours, minutes, and seconds. So I'm doing that. And then the declination is right here. So copy that into the declination spot, putting the colons again. And then I think that looks good. It looks like my star is visible above 30 degrees, above that horizon line, by several of the telescopes to which I have access. So that's good news. And I will go ahead and add the observation. So observation, settings, save and choose filters. And we don't want to use error inform. See below for more information. Oh, I guess it doesn't want that in the observation name. Okay, let's see if that'll work. Save and choose filters. Now it's happy. And the filter choice is going to be easy. We don't want any filters. So I'm just going to choose a high through filter. We'll collect all the light possible from these stars. And so I'll save and continue. And AURT looks like a fine choice. It looks like many telescopes could see it, but I'll just pick the first one that comes up. And add exposure. So now I want to do several different exposure times. So I'm going to do one exposure that's 30 seconds long. I'll add a row. I'll do one exposure that is 15 seconds long, add a row. One that is 10 seconds, and then one that's 5 seconds. And the reason for that is that I don't know what exposure time will be appropriate for these stars. So I'm just testing this. If we choose to study this system in more depth, we'll make multiple, we'll get multiple images at the same exposure time. But since I don't know which one's appropriate right now, I'm just gonna put several different ones. And then I will select my account. You'll just have one account that you can use, and then save and continue. It looks like the maximum exposure duration is 20 seconds for this right ascension and declination. So I'm just going to take away that 30-second exposure, 20 seconds. Okay, great. Save and continue. See if it lets me. Marvelous. And submit my observation. And then it's in there, and it's going to come back when it's ready. Its state is active. When the telescope has a chance to take that image, it will show as completed, and I'll be able to click on it to view the images that came back and download those for analysis on my computer. So when I do that, I'm going to take this image ID and put it right into the file. So I'll go back to my slideshow, play from current slide. And so I'll put my Skynet observation ID into this file so that your instructor will be able to look it up and find the stars that you imaged. So then we want to be ready. They might take several days to come back. The weather might be bad. The telescopes might need repairs. Something might happen. Regardless, we want to be ready to analyze them when they do come back. So you're going to do some analysis of a sample image file that's already there. And the first thing you'll notice when you call up the sample image file is that it's just a star field. How do you even know where your star is? Where is your double star? How can you measure the position, angle, and separation if you can't even find it? So the first job is to find your star. And luckily, Astro ImageJ will do most of that for you. So you download Astro ImageJ and install it, and then you have to update it. So you have to go to update even though you just installed it from this website that's linked up here, tiny.cc/AIJ. You have to go to the menu item that says Update Astro ImageJ and update it to the daily build in order for it to work as hoped for. So then you open up the test image from Canvas, and Astro ImageJ might automatically plate solve it for you, meaning that as you roll over the image, it'll show you what the RA and the dec of the stars in the image are, the right ascension and declinations. If it doesn't do that, then you have to play another video that will tell you how to connect Astro ImageJ to astrometry.net, which plate solves images for you. So that'll help find where your stars are in the image. Once you have found your stars in the image, you zoom in on the double star, and for the test file, that double star is at this right ascension and declination. So you mouse over the image until you find this right ascension and declination. That's the double star, and you're going to zoom in on it. And then you can adjust the brightness and contrast of the image using the histograms down below, so that can be useful. And then you alt-click on a Mac or middle-click on Windows to find the centroid of the primary star, which is at this right ascension and declination. It'll like automatically put a little circle around that star, and the very center of the star that it calculates based on the brightnesses of each pixel around the centroid will be right in the center of the circle that it puts. Even if you don't click right in the center, it'll be it'll figure out where the center is. And then holding down the mouse, you drag to the other star, the one right next to it, and let go of the mouse, and then there'll be a window of data that pops up, and you have to find one of those data values to enter into your homework sheet to show me that you actually got this process working. If it doesn't work, check out this video, which is another Astro ImageJ video that'll help you get up to speed on how to get Astro ImageJ to plate solve an image and find a star. Here's what you turn in: your answers to the questions, the table from the previous slide of your interesting stars, the associated Skynet image requests so that we can check on whether and when they come in, the stelladopy image of one of the star's orbits, because you have to have at least one star that has a solved orbit, and we want to see the past data on that star system so that we can see how much of the orbit has been mapped already. And then that window of data that popped up in Astro ImageJ when you analyze the test image, give us the end Y fits number from that data, and that will show us that you indeed got that working. And have AstroImageJ ready to analyze your images when they come in. So good luck, thanks for watching, and see you in section.